Hello, dear students. Today we are going to continue in Chapter 1, Activity 2. After you've learned in the previous video about the role of the salivary amylase, which is an enzyme in the saliva juice, and the food it works on, which is starch. Today we will determine how the starch is chemically digested into a reducing sugar. But first, I want you to imagine that you are eating a piece of bread. So what taste does it have? Yes, sweet taste. Oh, but bread is a carbohydrate food. So where did the sweet taste come from? Okay, don't worry, guys. In today's experiment, we will explain and answer this question. Just focus with me. Okay, first let's have a look at experiment number 1 in our video. As you can see here, we have two tubes, tube A and tube B. In tube A, we have starch and saliva, while in tube B, we have only starch. And both tubes are placed in a container filled with water bath at 37 degrees Celsius for 20 minutes and at pH equals 7, which is the neutral pH. And now let's look at the results after performing the iodine test. As you all know, the iodine test is the test that checks the presence of starch. So this iodine test was performed at 2 times, at the beginning at t equals 0 and at the end at t equals 20 minutes. At t equals 0, both tubes gave positive results with the iodine test, which means that the starch is present. After 20 minutes, tube A gave negative results, which means that there is no starch, and the tube B gave positive results, which means that there is starch. Okay, so this means that, or this shows the effect of saliva, which includes the salivary amylase enzyme on the digestion of starch. But in order to confirm the sweetness taste of the bread or of the carbohydrate or the starch, we are going to perform another experiment on the same tubes, but performing Fehling test on them. Okay, so in order to show that the starch is going to become a reducing sugar. So the same here, we will apply a Fehling test on both the tubes A and B. Okay, as we said before, A contains the saliva and the starch, but B contains only starch. At t equals 0 minutes, okay, both gave negative results. So this means that with Fehling test, this means that there is no sugar, okay? But after 20 minutes, tube A gave a positive result, which means that there is a reducing sugar here. But tube B gave negative result, which means also that there is no sugar. Okay, so this shows that the starch in the bread is going to be digested into a sugar. For that, we can feel or taste the sweet taste when we are eating a piece of bread. But here, let's have this concept map of the complete digestion of starch in the body. So starch starts its digestion in the mouth by the saliva juice, which contains the salivary amylase. The starch is going to be transformed into maltose, which is one of the reducing sugar. Also, in the pancreas, the starch is going to be transformed into maltose by the action of the pancreatic amylase in the pancreatic juice. So here we have two juices, the saliva and the pancreatic juice, which contain enzymes like salivary amylase and the pancreatic amylase. They will transform the starch into maltose. This is the first stage. And in the second stage, it will occur at the level of the small intestine, where the small intestine contains the maltase enzyme in the intestinal juice. Okay, so maltase enzyme is going to transform the maltose received by the pancreas and the mouth into glucose, which is another reducing sugar. So here we can see that the starch is going to give a reducing sugar. For that, we can taste the sweet taste in the bread. Okay, As a conclusion here, amylase is responsible for the digestion of starch paste, whether salivary amylase or pancreatic amylase. The salivary amylase needs a neutral medium, which is pH equal to 7, to digest the starch, especially in the mouth. And the final product obtained from the digestion of starch paste is glucose in the small intestine. The digestion of starch needs a duration of 20 minutes, as we saw in the previous experiments. Now let's have this in practice together. I'm going to read these 4 questions following each other, and you will pause this video for about 2 minutes and try to answer the 4 questions. So the first one is, name the juice that is secreted by the salivary gland. Name the enzymes needed to digest the starch paste. State the pH and the temperature needed for the activity of salivary amylase. Name the product of starch digestion by the digestive system. So pause for 2 minutes and answer these 2 questions. And now here are the answers. Of course, the answer of question number 1 is going to be the saliva. So the saliva secretes or the salivary gland secretes the saliva. And in number 2, the enzymes are the amylase and the maltase. The amylase in the mouth and the pancreas, and the maltase in the small intestine. About the pH is going to be 7, and the temperature is going to be 37 degrees Celsius, which is the normal body's temperature. For the product, it's going to be the glucose, which is a reducing sugar, and gave a positive test with the Fehling test. And now, guys, you will have this as a molecular simplification of starch as a homework. You have to complete it. I already named each step with a letter. So here you have a letter A, B, C, D, and E, and you have to complete it using the enzyme needed or the product obtained after each enzyme. You can watch the video more than 1 time in order to answer it, and you can also look at the concept map that I showed you that will help you to fill it out. Have a nice day. Bye.